So in this video, we're going to use GeoGebra, a web app that anyone can use to build a right triangle. And once we've done that, we're going to take a visual look to start us off at the Pythagorean Theorem. So here we have the GeoGebra geometry app. You can get to it by going to geogebra.org and click the geometry link right here, or you can just type in directly geogebra.org/geometry. So what's a triangle really? Well, it's got three sides. For the first side, that's pretty easy. We can just use a segment. Now, we don't just want any triangle, we want a right triangle. So one thing people are tempted to do is just try the best they can, but we don't know if that's really a perfect 90-degree angle, so we're not going to do that. Instead, what I'm going to do is draw a perpendicular line to this segment through this point, and then drop a point onto that line. And then I'm going to hide, not the segment, that line. And then drop a segment there and a segment there, and we have a perfect right triangle. Now, the big advantage to this is by doing it that way, we can drag the points around. Okay, so A and B are just the sort of set points, and then C is any point on the line that's perpendicular to that segment. So that lets us try out a lot of things really quickly, and although this isn't a proof technique, it can be a pretty good way of finding counterexamples. So it tells you if something is worth trying to prove in a way. Okay, so we got a right triangle. So now we want to talk about the Pythagorean theorem. So I'm going to draw some squares around it, again using the regular polygon tool with 4 vertices. There. So here's what I want to point out. Right here, we have one side squared. We could call that A. In fact, we can go in and adjust the names of these things. So like I'm going to call that A. Yeah, I know some of these are already taken. Okay, so I'm going to change my point names to X and Y and Z, because those aren't going to interfere with anything. And what I'm going to go through and do is hide those. Well, I'll leave that, but I'm going to hide the label on my points. And I want to show the label on my segments, but again, I want to rename that segment as A. Why are you not letting me use A? If I capitalize it, will you like that better? Sometimes it plays up. Okay, we'll use capitals, no problem. And I'm going to hide the points that I'm not using for anything. Okay, and then here we have this segment. So this one I'm going to rename B and use capitals because it seems to like that better. And I'm going to show that label. This one I'll call C. Remember, the hypotenuse is always C, of course. I don't know why we don't just call it H for hypotenuse. That would be so much easier. Okay, so now we've got our A, B, and C sides, and what we're saying here is that A squared plus B squared equals C squared. So that's something we've done by drawing squares off of each of these sides. But does that really add up? Well, let's find out. So another tool that GeoGebra offers is area measurement. So I scrolled down in the areas to right there. And I can just click each one. Sorry. I can just click each one, and then I can grab whatever is handy as far as a calculator goes. I've got my Casio graphing calculator here, and I can just say, okay, does that work for this particular example? So let's see, a squared is 10.7, so 10.7 plus 24.8, that's b squared, is 35.5, which is my c squared. Okay, so that works. Now you can get rounding errors as you move these around. You can see that it's rounding to one decimal place, so you can line it up in such a way that it might... Okay, see how this one's got a couple of point ones? Well, that doesn't work. Okay, here. This one's got a 0.2 and a 0.4. You'd think it would end in a 0.6, but it comes out to 0.7. So you can get rounding errors because of just the way that it's applying that. And if you don't want to have that happen as quickly, you can go into your settings and say, okay, instead of 1 decimal place, let's get 15 decimal places. Okay, so even at the end, you could still have a rounding error, but it's a lot further down there. So it could help you possibly be more confident in what you're seeing. But remember, these are estimates. So we're not going to draw any big conclusion about how it's always going to be perfectly accurate from estimates, but we can see from this that it sure seems to be the case that this side squared plus this side squared comes out the same as this side squared. Further on, what we're going to need to do is take a little bit harder look at why that happens.